So this video is to explain how light is formed, okay? So in order to do that, we actually have to understand how electrons behave when absorbing and releasing energy. Okay, so we're going to take one element as an example. Why don't we take nitrogen? And the first thing we're going to do is to write out its electron configuration. So if you remember how to do that, we go from 1s2, 2s2, and then we have to count. It's in the p orbital, so this would be 2p3. Okay, so what we also need to do is to draw a model of our element. So we'll start by drawing our nucleus, right? And within our nucleus, we have some protons, which are positive, and we have some neutrons, which are neutral, right? So our nucleus is overall positive, and surrounding the nucleus are our electron rings. And nitrogen has 2 energy levels, right? Because it's in the second row, so it has 2 energy levels. And we'll just go ahead and draw our electrons here. So 2 in the first one, and then 5 valence electrons. 4, 5. Okay, so nitrogen is one of the most common elements found in the atmosphere, actually the most common element. And so what happens is the sun, there's our sun, exudes light, right? And so what the light rays are actually going to do, the light rays have energy. Oops. And these rays of light are actually going to hit electrons in this element. And when the light hits the electrons, since the light has energy in it, those electrons are actually going to absorb energy. And when they absorb energy, they're actually going to jump from what we say ground state, and it jumps to an excited state. An excited state means it has a lot of energy in it. It's really mobile, it's really moving, it's kind of vibrating in place. Think about like if you take your dog outside or you throw a tennis ball, it's in a really excited state, right? It has a lot of energy. So because of that, this is going to jump, this electron jumps from one energy level to another, okay? And again, this is absorbing energy. So in an excited state, electrons can't exist in excited states for very long because it's unstable. Okay, so think about like balancing on a balance beam, or just think about using energy, right? Think about playing a high level sport, or think about sprinting. You can't do it for very long, right? It's not sustainable. And eventually that electron has to go back down to its ground state. And if it absorbed energy to move up, then it has to release energy to go down. Okay. And when it releases energy, it actually releases it in terms of wavelengths and frequencies, which the simulation this week will kind of explain in more visual detail. So it will actually give off a wavelength of light. And we'll talk more about this later too, but colors are determined by the wavelength or frequency of the electrons. So nitrogen has 2 energy levels, but as we can see in our periodic table, like xenon, it has 1, 2, 3, 4, 5 energy levels. So there are constantly times where electrons in different energy levels that are moving from, in this case, it could be moving from the 3rd one to the 5th one. It could be moving from the 2nd to the 3rd. Each time it moves from one energy level to another one, it's going to give off a different wavelength of light. So where the electron starts and where it goes matters. If you remember the flame lab that we did, where we could kind of see different colors of light, that is different elements going from different energy levels to give off different colors of light. The simulation will go into this in more detail as well, but just to review real quick, light comes from energy being absorbed, electrons absorbing that light energy to go to an excited state up here, and then releases it because it's not stable to stay in that excited state for long. And as soon as it releases energy, it releases it in the form of colors or light wavelengths, which have specific colors associated with each wavelength. All right, check out the simulation. I'll talk to you guys later.